Hello, I'm Steve with Renesas Timing University. In this video, we're going to be talking about the PLL. PLLs are everywhere. There's a PLL in your wristwatch, in your laptop, in your cell phone, and they have many applications. A PLL can take a single incoming reference and generate multiple frequencies from it. It can also take an incoming jittery clock and create a clean copy. And thirdly, it can be used as a zero delay buffer in order to manage skew across a large PCB board. So what does PLL stand for? PLL stands for phase locked loop. And a PLL has three basic building blocks. The first is the phase detector. Now, it's also known as the phase frequency detector. The second one is the loop filter. And the third is the VCO. As the name implies, there is a loop. So all of these are connected, and there's this feedback loop from the VCO back to the phase detector. As I previously mentioned, there is an incoming signal. This can be a reference clock from somewhere in the system. It can be a crystal or an XO. So the shape can also be a square wave or a sine wave. We're going to use a square wave in this example. Now, the PLL, as I mentioned, creates some output. So we're going to put an output coming from the VCO. So the phase detector is constantly monitoring the output signal from the voltage-controlled oscillator and comparing it to the input reference. So let's, in this example, say that this is a square wave coming from the VCO. Now, this operates very similar to the cruise control in your car. So when you set the cruise control, you set a certain speed. Your car is constantly monitoring how fast you're going. We can think of the VCO as being the motor. And so if we need to speed up, we increase or press on the gas pedal, right? So this phase detector is constantly monitoring, just like a cruise control system, how fast is this loop running. If it detects that the loop is running too slow in comparison to the input reference, then it sends information to the VCO. So let's kind of skip the loop filter for now. So it tells the VCO speed up or slow down, just like the cruise control would do in a car. So as the phase detector tells the VCO to speed up, it speeds up until the feedback signal is running as fast as the input signal. Now, the job of the loop filter is to reject high frequency noise or high frequency information. So it's a low pass filter. So the phase detector is updating at a very fast rate, but the loop filter is rejecting all the high frequency information. Now this phase detector could be sending either like a digital word or voltage to the loop filter. The loop filter is then sending a voltage to the voltage controlled oscillator, and it's setting the profile of how fast this PLL is responding. The higher the frequency of this cutoff low pass filter, the more faster the PLL is able to respond to any fluctuations in the incoming signal. So as I mentioned, there is this output. So in this example, if we have a 25 megahertz input, we would have a 25 megahertz output. Now, PLLs can get very, very sophisticated. There are many things that can give it much more flexibility. For example, we can have an output divider, a feedback divider. We can have different topologies for the phase detector and a loop filter. But as long as you understand the three basic building blocks, the phase detector, the loop filter, and the VCO, then you're off to a great start in understanding how a PLL functions. So for more videos and more details on the additional features that a PLL has, tune in to our channel and they'll be available there. So thank you so much for watching this video.